Hi there. Today we're going to move on to a new topic. We're going to speak about functional notation. Now, really, when it comes to thinking about a function, there's nothing really big to consider. A function is a set of instructions which changes one group of numbers into another group, and you have dealt with this, especially over second year and third year so far. So, a function is really just a formal way of talking about an equation. A function is the name of an equation. So, looking at this top bit here, it says y is equal to 3x plus 1. That takes an x value, it multiplies it by 3, which is the 3x, and then 1 is then added to it. And the result of that there is what the corresponding y value is. And what you'll learn in mathematics, especially the more we go through topics such as straight line, quadratics, trigonometry, etc., is whenever we have any equation, that equation is made because a certain process has happened into the x value to turn it into the y value, and it's that pattern of changes that creates the nice shapes of graphs that we get. The most basic ones that we can have are straight line graphs, and we will speak about this topic when we come back to school in August. That just takes an x value, transforms it into a y value, and the pattern that makes joins the dots up into a straight line. In function notation, the rule is written as f of x is equal to 3x plus 1. So we say f bracket x as f of x. So it's important to note here that f of x and y are the exact same thing. Y is equal to f of x. So if you ever see a notation written as f of x equals, that's the exact same as saying y is equal to 3x plus 1 in this case. Okay, so y is the same as f of x. Just a little bit extra for you. You don't have to worry about this last line here really until we get to higher. It says in a function, the numbers that go into the function are called the domain. So anything that you substitute into a function, that's the domain, and the answer that we get out of that is called the range. So a bit more than that when we get to higher, so don't worry too much about it just now. But in order to work with functions, what you have to be good at is substituting into formulas. So this really requires a good bit of your algebra substitution knowledge. So let's take a look at example 1 then. So we've got f of x is equal to 2x plus 3. And the first thing that I want to do here is I want to find the value of f of 5. So really what this means is I want to take 5 and I want to substitute 5 into the function wherever I see an x value. So if f of x is 2 times x plus 3 and 5 replaces the x, then f of 5 is going to be 2 times 5 plus 3. So let me write that out then. So f of 5 is going to be 2 times 5 plus 3. The 5 in this case just replaces the x. And then we just work that out. So it means we get 2 times 5 is 10 plus 3 is 13. And that's the answer. So really that means that for this graph, if I have an x value of 5, if I put it into the equation, the corresponding value that would give me that straight line would be 13. Bit more than that when we get to straight line. I know I'm asking you to just trust me with a bit of a leap here. All we want to do is get practice in evaluating functions just now. The next one that we have here is f of minus 1. So for the exact same function, we're going to do the exact same process. This time, if f of x is equal to 2x plus 3, then f of minus 1 is going to be 2 times minus 1 plus 3. So remember, you do your multiplication first. 2 times minus 1 is minus 2, plus 3 is going to give me 1. The next thing we have f of a. So again, because it's a letter, it doesn't matter one bit. We still substitute it in to replace the value of x, and that's all we're doing here. So if I want to work out f of a, then the same thing that I did with the numbers, I'm going to replace my x value with a. That's going to be 2 times a plus 3, which just simplifies to 2a plus 3. So when we introduce letters, we can never ever get to a definite number because we don't know what that letter is. So we just have to leave it as 2a plus 3. And then last bit in this example, it says f of 3d. So in the exact same way, we're going to take 3d and replace the x with that. So f of 3d is equal to 2 times 3d plus 3. So 2 times 3d is going to give me 6d. So I just get 6d plus 3. And that's the most basic way of substituting into functions.